I'm just going to do a sample problem from lesson 6.6. This is not a very complicated problem, but it does involve converting units. And we talked about dimensional analysis, so this is just a sample. So if you read the problem, you're sitting in your chair, whirling around space with Earth as it moves around the sun. So we're here, going around the sun. And in the problem, we're given the distance from Earth to the sun, and how long it takes Earth to go around the sun, which you know is about 365 days. So speed is just distance divided by time, and rate times time is equal to distance. So if we want the rate, we would have to do distance divided by time. But our distance is given in meters, and our time is given in days, and our answer is supposed to be in kilometers per hour. So I'm just going to go through the steps of how you would set that up with dimensional analysis and convert the units. So in order to do this, our total distance is the circumference of our path. So that's pi times the diameter. Since they only gave us the radius, we had to double the radius. So to figure out this problem, you would take that circumference, 2 times 1.4957 times 10 to the 11. And remember, that's in meters. And divided by 364.25, and that's days. And so to show the dimensional analysis this, we want to get rid of days. So we know that 1 day is the same as 24 hours. So when we do that, days cancel out, and we're left with meters per hour here. So that's a step in the right direction. But now we want to get rid of meters. So we know that 1,000 meters is equal to 1 kilometer. So now we can cancel out meters, and our final answer is just left with kilometers and hours. So we can just multiply everything in the numerator. So I'm going to do that. So when I do that, oh, I left the pi off here. When I do that, I get about 9.3977, and I left the times 10 to the 11th there. And I'm going to store that on my calculator. We can practice that tomorrow. And now I'm going to divide the bottom number. So those are the two numbers that I have for multiplying the numerator. And remember, our units here are kilometers per hour. Now we just take the black number, the number in the numerator, and divide it by the number in the denominator. And when you do that, you come up with approximately that. And in the original problem, it says round to the nearest 100 kilometers. So that would be to the 100th place. So you're going to round to the 100th place. So 107,500 kilometers per hour. So when you do your homework, today, try to set up homework in the style of this dimensional analysis to show how your data is worked out. Questions in class?